Today in this lecture, today in this lecture, we will explore unit vector. I am not starting it from starting. What is a vector? Types of a vector? No, I am not going to talk about this. What is vector? Types of vector? Yeah, we have a type of vector which name is unit vector. In details, we will explore it as much as we can do. Okay. Uh, so I hope you are crystal clear that yes, our focus will be on unit vector. Then ahead of this discussion, we will be discussing. Okay. So one point is clear that I am not starting from meaning of a vector and types of a vector. Clear? How to represent it? No. I am assuming that you are a student who know little bit about the vector. Clear? So let's start our this journey. This journey in this uh, unit vector. From this word, what are you understanding? From this word, what are you getting feeling? As I said that I am assuming you are a student, so I hope you will be familiar with this unit vector. Unit means magnitude is 1. This is the definition of a unit vector. Magnitude is 1. Uh, so we were talking about unit vector. Uh, Definition of this would be what? A vector was magnitude, a vector. Definition of this would be always what? A vector whose magnitude is 1. Okay, whose magnitude is 1, and that's it. What you would ask, what about the direction? So, yes, magnitude will be always 1 for this unit vector, but it is used for direction. For direction. Okay, means whenever you will see use of this unit vector, you will realize that yes, here direction is being highlighted. You will realize this point. I am telling you use of unit vector. So here I said that magnitude is 1 and it will be always, it will remain always. So when it comes to direction, then anybody will use it for a specifying direction. Even we will use right now. So I want to tell you that unit, symbol of unit is nothing but, let's say we have this magnitude and we will denote this unit as cap. This is a cap. It means magnitude is a 1 and this cap is for direction. This cap is for direction. So we can completely say this is a direction, and here magnitude is a hidden, which is 1, which is a 1. Which is a 1. Now look at over here. This a vector. Definition of this a vector is what? According to you, you would say magnitude multiple direction. Magnitude multiple direction. Even we can say in this vector, this arrow is represented for direction and a is a magnitude. So this is the definition of this vector. Okay, so magnitude multiple direction. Now, from this, I am telling you about this unit vector. From this, right now, this A vector, okay, magnitude for direction, magnitude. So tell me, magnitude of this would be what? You should be familiar already that magnitude of this any vector or any vector, just we apply this mode, and now it's a complete magnitude of this vector. Okay, so it is a magnitude of this would be what? This mode of vector a multiple direction. So direction, for direction we will represent this side a cap, a cap. Okay, here one is a hidden, one is a hidden. So for direction we represented this a cap, this a cap. Okay, I hope now you are getting feeling. This a cap, instead of a you can write anything here. Whenever you are representing this symbol, you are saying to yourself that I am representing, I am showing direction. Just for direction we used this, and for magnitude we used this. So this and this both are different, not same, not same. Clear? Now it can be written as a multiple a cap. This is the equation. From this you can get a cap is equal to something. From this you can get a is equal to vector a upon a cap. Can I say that a cap is equal to vector a upon a? You can say, or even you can say a cap upon a cap is equal to uh, vector a upon a magnitude of a. This and this equal. Okay, I hope this part is clear. How did it come? How did it come? So from this came from this. Even we will use this part in our upcoming question. That's why I'm telling you this. Okay, did you understand something? Okay, so ahead of this, not a topic, but but look at our, when we say magnitude of this a is what? Just this, like that we write. Okay, magnitude of this vector, this will become. But we are saying that direction is along with this vector. It means question is saying direction is along with the a vector. So what are you understanding by this line? You are understanding that we have already a vector. This vector, it can be like that. This is a vector. Okay. Now, direction. What is the direction? Where is the direction? To visualize, you can say it is already saying that direction is along with this vector, this vector. So we have already this vector, and direction is nothing but this one magnitude and direction, one magnitude and direction. This is your a cap. This is your a cap. This is nothing but direction is along with the a vector. Here you can also say that this a vector is parallel to this a cap. Yes, it is happening over there. That's why you can say it's a truth that a vector is parallel to a cap. Now let's break down it in details. Hold on. Here we have a horizontal line, this horizontal line, okay, this horizontal line, and one is a vertical line. This is a vertical line, okay. Origin point is known as this place. Now here I am saying there is a person. There is a person who is covering a distance with 10 meter per second. 10 meter per second in this direction, in x-axis. Clear? And another person. There is another person. B person, I will say. So this is a person, and B person is covering some distance with this speed, 20 meter per second in y-axis, in y-axis, in y-axis. Now, how would you write it? How would you? So here you would say velocity of a person. Velocity of a person. Okay, this velocity of a person. You would say this is covering. You are understanding that velocity of this a person is how much? 10 meter per second, isn't it? 10 meter per second. But in which direction? This is the only magnitude. 10 meter per second. This is the only magnitude. It is not it's not providing direction. Now you want to know in which direction this a person is moving. A person is covering some distance with this much velocity. In this diagram, we can say this person is moving in x-axis. So along x-axis, along x-axis. Anybody will be able to interact that yes, yeah, this y is moving along x-axis with this much speed, and it is covering some distance. Now we have one more person, which is B. Velocity of B person. It is moving with a speed of 20 meter per second. 20 meter per second. But question is, in which direction? Question is in which direction? So here you would say along y-axis. Along y-axis. Are you understanding? Along y-axis. This is how we can tell to someone that somebody is moving with this much speed in this direction, in this particular direction. This is how we can explain. But rather than writing this along x-axis, along y-axis many times, there is another way. There is another way to explain it in short, and it will be convinced to someone. This will help you to convince someone with an easy explanation. Yeah, this is also a way. Through this, anybody can explain their conservation. So, what is the other way? Okay, what is other? Other is nothing but here. Remember, other is nothing but when it comes to vector, when we jump into vector, then rather than saying x-axis, we say I cap. We say I cap. Clear? And instead of y, you say j cap. In details, we are exploring it. And third axis, which is known as z axis, and in vector, this is called as a k cap. Clear? K cap. Whenever you would be saying this I cap, it means you are saying somebody is moving in x-axis. This is what somebody will understand. And when you would say z cap in y-axis, a object is moving. Okay. So this I cap, k cap, and j cap, as we know that this cap is represented for direction. So yes, when you will write this I cap, it means you are providing direction. Clear? 10 meter per second. I cap. So right now we have three axes, but our focus is on this axis. This was another way, but let me complete this. Velocity of A is nothing but 10 meter per second I cap. Clear? Or you can say 10 I. 10 I, but let it be. Velocity of B, then here you would say j cap. This is another way. I cap, j cap. I cap, j cap. Now, look at over here. This is complete. This was a little bit example just for understand this I cap, j cap, k cap. More about this thing, I can say. Here, unit vector along x-axis. Unit vector along x-axis. We say that this is nothing but I cap. Unit vector along y-axis. We say j cap. And what about z-axis? Z-axis, you would say k cap. You would say k cap. But as you are familiar that we have also minus x-axis, we have also minus y-axis, we have also minus z-axis. What about all this? We cannot ignore all this. So these are three axes. Three more axes. This positive, this positive, this positive. So here we have minus x axis. For this we represent minus I cap. minus y axis. For this we represent it as minus z cap. Okay, then we have minus z axis. For this we represent it as a minus k cap. I hope you understood something. Okay, now I was saying that a object is moving in x axis. So in the language of a vector, we say that a 10 meter per second, 10 meter per second, a object is moving in x in I cap, in this direction. But what about if I say, what if I say that the same object is moving instead of in this direction, the same object is moving in this direction, which is x minus x axis, and now what will you would say this is moving nothing but minus 10 meter per second, 10 meter per second in minus I. Now you would understand that yes, a object is moving with this much speed, but in a positive direction of a positive I cap. Okay, that is how you will understand. Okay. Now, shall I erase it? Shall I erase it? If yes, let me erase it. Another example, let's take another example. I am saying there is a one particle. Okay, there is a one particle. It can be bird, it can be this particle. This is nothing but C. I would say C. Okay, and I am saying position of this vector is nothing but 4 comma 3, 4 comma 2, 4 comma I would say 3. Okay, 4 comma 3. Now I want to position vector. Do you know what is a position vector? Do you know what is a position vector? I am linking unit vector with the position vector. Don't you think that unit discussion of the unit vector is done? No. Position vector here. It's very simple. We are going to find the location of a particular vector, and this is what vector, position vector. So here, this is a location of this straight particle. But how to tell? What is a reference? Where is a reference? So reference is nothing but this origin point. With respect to origin, we can say that this is our position vector of this C, and this will be represented by this. Instead of R, you can write anything. So this was here we drawn this line from origin, because I was saying that find the location of this vector with respect to origin. That's why. So for reference point can be anything. It is not a fixed that origin is the origin. No, reference can be anything. It can be another vector. It can be origin. It can be object. Okay. So if we, when you are going to find a location of any particular vector, so observe what is a reference point, then identify. Then identify. So in this, our reference point is origin. So from origin, we will draw this vector from origin till the till this vector. Now it is the same. This is saying that in this axis, we will have to cover how much? How much? This 4. This 4 in x axis 4. Okay, in x axis you in this particle covered 4. Okay, 4 distance you can say. And in y axis, in j cap, you would say 3. This is a 3. This is nothing but 3. So this is y and this is a x. In other way, you can say this is a I cap and this is a j cap. Overall, you are getting nothing but position of a vector is position vector of R is nothing but 4i cap plus a 3j cap. This is position of this particular vector 4i plus 3z. Now here, let's say we have second vector which is over here, and this is a -5, -4, and -6, and -6. Not every. And reference point is origin. Reference point is origin. No? You will draw like this. Okay. No problem. Now, in mathematic way, how to write this resulting this R vector? You would say, let's just say this is an n vector. Okay, this is n vector. So position of n vector is nothing but this is I cap and this is a j cap. Clear? In that case, this I cap is in negative. This is j is also in negative. So can you write this like that? 4 I cap minus j I cap. So this is the magnitude is how much? 6. Magnitude is -6. This is how position of any vector is represented. This is how. This is how. Now, okay, we were able to identify position of vector when we had not to when we had two axes. But what if when we have a 3 axis? In that case, how to find when we have 3 axes? In that case, is it possible? Yes, it is possible. From this, you are crystal clear that we have 2 axes. You will have 3 axes when one more will be added. For example, this is 5, and here we have 2, like that. Now, with the evidence, we can say that the equation is giving us 3 axes. 3 axes. So this is a saying that this C vector, moved in x axis 4 meter, in j axis, in y axis 3 meter, in z axis 5 meter. Okay, so again position of n vector is what? This, remember, this first will be I cap, second will be j cap, and third will be k cap. X, y, z. First will be always x, and second y, and third z. Don't change this orders. Okay, it will be always fixed. So first is 4j, 4i cap plus 3j cap plus 5k cap. This is how position of any vector will be represented. It's a complete location of this vector. Okay, this is complete. Now next we have position of this was C vector, position of this n vector. So in that case we have I cap, j cap, k cap. I cap is -4, this is -6, and this is a 2. But remember, this will come in -2 because in this z will be in minus. I think so. So -4, -6, -2. But it's not correct way. This is not a correct way. Any unit vector, any vector. So -4 I cap -6 j cap -2 k cap. This is the position of this n vector. Clear? Are you understanding? Have a look for a few seconds. Now one more point I would like to add over here, because this will be part of this. Okay, I was saying find the location of this vector with respect to origin. This was our reference point. But what if we have over here, let's say this A and this B vector. Okay, this A vector, this B vector. All these two vectors are in this coordinate, in this section. And question is saying find the location of a B vector with respect to A vector. In that case, our reference point is going to be A vector. This is our reference point, not this origin. Question is the same. I am not saying. Okay. So you will write like that: position of B vector with respect to A vector. That is how you will write, or you can say this R vector, position of this R, we are representing it for position. So position vector of B with respect to A. In short, you will represent this line in this way. Now it can be asked like that position of A vector with respect to B vector. In that case, just opposite of this, position vector of A with respect to b vector, like that. Clear? Clear? That is how you will write. Our focus on this was on reference point. What is going to be reference point? So in this, our reference point is this a vector, and in this our reference point is b vector. Clear? And question is saying find the location of this v vector, and in this case find position of a vector, but with respect to this reference point. Okay. So let's understand this by a question, by a example. You can say by an example. By an example, if this is a and this is a b, 4 comma 2, not 4, 2 comma 4, 2 comma 4 and 5 comma 6, 5 comma 6, 2 comma 4. Okay. Question is asking you what is the position of this b vector with respect to a vector. Okay, so position of v vector with respect to a vector, it means b with respect to a. In that case, just we will have to write like that. This x2 minus x1 plus y2 minus y1, that is how you will find position of this particular vector. x2 minus x1, y2 minus y1, z2 minus z1. And we are already, we all people are familiar with this, and it is taught in the discussion, in the study of distance formula. x2 minus x1, y2 minus y1, z2 minus z1. Yeah, same here we will do. Remember, x2 minus x1, then plus, then y2 minus y1, then plus. That is all. So x2 is nothing but 5 minus 2, and this is I cap, then plus y2 is a 6 and y1 is 4, and then z cap. This is your position vector. So 3 I cap plus 2 z cap. This is your answer. This answer is saying just you will have to cover 3i from here. You will have to go 3i ahead of this 3i, and then 2z upward. Then you will be at this place. You will be at this place. This is what is the meaning of this answer. Okay. What if we have now 3 axes? In that case, same method we will apply. Same method. Position vector of b with respect to a. Now x2, yeah, same, x2 minus x1, y2 minus y1, z2 minus z1. 5 minus 2 I cap plus 6 minus 4 j cap, then plus 4 minus 1 k cap. This is your final answer. 3 I cap plus 2 j cap plus 3 k cap. This is your final answer. Are you understanding? It cannot be ignored, brother. It cannot be ignored. Not at all. Let's see next part. Now next part. Magnitude of a vector. How to find the magnitude of any vector? Magnitude of a vector. It is a different from the previous lecture. Magnitude of a vector means magnitude of this would be what? We have this vector and this ax I cap, okay, like that. Then bj aj again aj a y z cap, then a z k cap, a z k cap, okay. Here one point is moving in three axes. One point is moving in three axes. This in x axis, this in y axis, this in z axis. Now here, when it comes to magnitude of vector, this is how you will do. Magnitude of this vector, this is already a vector. So question is asking, let's say question is asking magnitude of this vector would be what? So nothing, magnitude of this vector under root of I cap square plus j cap square plus k cap square. Am I correct? Am I correct? No. Not a direction, okay. Magnitude. A square of magnitude. This ax a square, ay a square plus az a square. Az a square. This direction will be removed. When you will apply this magnitude, this mode, then direction will be removed. That is why this mode is used, so that we can remove direction. So that's why you will not write over here direction. This I cap, j cap, k cap, okay. So a square of this x square of a square of this and this will give you magnitude of this vector. Now let's understand this with an example. We have a question. A vector 4j plus 3k cap. Question is find magnitude of this given a vector. In that case, just use this formula. Magnitude. This is not magnitude. This mod is magnitude. In that case, just simple Pythagoras theorem. I think so. We are using Pythagoras theorem. 4a square plus 3a square. That's it. This is not difficult. 16 plus 9. 25. So 5 is your magnitude. Try to observe over here. You were finding magnitude. That's why you you got a number, simple number, not a k cap, j cap, not this that. Why? Because only we were finding magnitude, and to find magnitude we used this formula, this simple formula. If you want to find magnitude with the direction, then you will have to use different formula. So for a scalar, you can use this formula. For vector, you will have to use a different formula. Okay. Now next question. It's the same. Okay, when we will have this positive axis, in that case we will be able to do solve. But what if we have negative axis? In that case, let's see this a vector, and here we have nothing but 4 I cap, 4 I cap. Okay, 4 I cap minus 3 j cap, minus 3 j cap. This is negative axis. Remember, when it comes to magnitude, everything will be positive, everything, because you jumped into magnitude. That's why. So magnitude of this a vector will be nothing but 4 square. This can be written as minus 3 square. Okay, so this will become 16 plus 9, and it can be written as a. Yes, this will become 25. Most of you would say, can't we write this plus minus 5? No, this is wrong. Remember, you are in vector field. In vector field, this is considered wrong. Okay, only positive. When you jumped into magnitude, the negative will be ignored, and positive will be selected always. This is your answer. Okay. Okay. Now another a cap, 2 I cap, 2 I cap plus 3 j cap plus 6 k cap. Now magnitude of this would be 2 square plus 3 3, 2 to the 4, 3 3 is 9, 6 6 is 36, 13 plus 36. Then we have 9 and 4, so 7. This is magnitude. This is the magnitude of this given vector, 7. That is how you will find. Okay. Now next a vector, then 3 I cap minus 4 j cap plus 5 k cap. Clear. Magnitude of this vector will be 3, and this will become positive at the end. So 4 square plus 5 square, 3 3 is 9, 16, 25. This 25 and 25, it will become 50. 50 in under root. So here 20 2 to the 4, 4 5 is a 5. 5 into root of 2. This is the complete. Till here this is also complete. But if you want to go ahead of this, then this step will come. 5 root of 2. It's a final. I hope you are understanding. Have a look for a few seconds. Let me write some questions. Let me write some questions. Three I minus 4j plus 5k cap. Then next we have I cap plus j cap plus k cap. Then next we have solve all these questions. Now, this is for you. Here in this we will get nothing but 1 square, then again 1 square, then again 1 square. At the end we are getting root 3. Okay, in this case, magnitude of this given vector is 1 square, then minus it will become positive, then again positive. Okay. Okay. A square. At the end you will get again root 3. Of course, again root 3. This was solution of all the equation. Next we have this 4 I cap minus k cap. Solve this. Look at over here. I cap. Okay, so magnitude of this will be 1 square plus 1 square. At the end you will get root 2. J cap plus 2k cap. J cap plus 2k cap. So here magnitude of this given vector will be 1 square plus 2 square. At the end you will get root 3. Not root 3, but 5. 2 to the 4, 1 5. J minus 3. J cap minus 3k cap. So here magnitude of this given vector will be 1 square plus minus 3 square. At the end you are getting 1 square plus 3 3 is a 9. So it is a 10. 2 to the 4, 4 to the so I think it will be nothing but 2 to the 4, 10. So I think it this 2 root of 5. 2 root of 5. Am I correct? 2 to the 4, 4 to the 10. Have a look. Now next. Next is 1 by root 2. 1 by root 2. Yeah, in that case, same. It's not too much difficult. Vector of this given magnitude of this vector 1 by root 2 to the raised to power 2 plus 1 by root 2 raised to power 2 raised to power 2. So this is nothing but 1 by 2 plus 1 by 2, 2 again 2, this 1. Magnitude is 1. Magnitude is going to 1. How? You can see process of this one answer. Next, same. Only we will replace this positive by negative. I cap minus 1 by root 2 j cap. Okay. Again, answer would be 1. You know, answer would be 1. Just we replaced this positive by negative, and magnitude is the same. You can see 1 by root 2, 1 by root 2. That's why 1 will come again. Now next, 1 by root 3. Okay, again 1 by root 3. Okay, again 1 by root 3. But directions are different. Magnitude of this would be 1 by root 3 square plus 1 by root 3 square plus 1 by root 3 square, then that is in under root of this. Now 1 by 3, okay, 1 by 3 again, okay, 1 by 3 again, because 3 3s are 9, and 9 is the perfect square of 3. That's why 3 came again. After simplifying this, you are getting nothing but you are getting again 1. Am I right? Yeah. Now next question. 236 j cap minus plus k cap. Okay, I cap. Okay, no problem. So 2 square minus, not minus, plus minus 3 square, then plus 6 square. From this we will get magnitude of this given vector. 2 to the 4, 9, 36. 9, 4, 13, 49. This is a perfect square of 7. 7 is the magnitude of this given vector. Okay. Now next, just have a look for a few seconds. Here I have told you that vector A is equal to nothing but magnitude multiple direction, magnitude multiple direction, and it can be written as uh, this magnitude, which is A, this mode of this vector multiple for direction, we represent it as this symbol, by this symbol. Now we found this magnitude of given vector. We found this. What if only we want to get the direction? In that case, just you will have to write this a cap, and then this will be as it upon mod of a vector. From this you will get only from this I am saying from this you will get direction a cap, and in coming question we are going to apply this equation, or you would say formula. In separate, I would say when you will simplify this, you will get 1. How? Let's see. This is vector. No, let it be. Focus on this. When you want to get the magnitude of any vector, then just use this. Okay, under root of magnitude square plus magnitude square plus magnitude square, like that. Okay, magnitude of I cap a square, like that. And when it comes to only direction, then just use this formula, simple this formula. To get a cap, you will have to divide this vector by magnitude of this vector. Divide this vector by magnitude of again this vector, then you will get a cap. Now let's take a question for this. We have this vector, and question is saying 3i 3i plus 4j 3i plus 4j. Okay. Question is saying find a unit vector. Find a unit vector along this vector. Find a unit vector. Unit vector which means a cap. Unit vector which means a cap. Of course, when question will say find a unit vector, then we will use this formula so that we can get this a cap. It's not difficult once you understand it. Clear? This is a complete question. Of course, you will use this formula. Now, how to use this formula? Let just say over here. For calculate this unit vector, first of all write this 3i cap plus 4j cap, and then divide this by magnitude of this. So magnitude will be nothing but 3 3 is a 9, 4 4 is a 16, 16, 25, 25, 5, and it can be written as 3I cap upon 5 plus 4j cap upon 5. This is your direction. This is a unit vector. Now next. Three I plus 4j plus 5k. Find a unit vector along this vector. So a cap will be is equal to this 3I 4j plus 5k. Don't remove this direction because we are going to find what direction. That's why don't remove this I cap, j cap, k cap upon magnitude of this. So 3 is a 9, 4 is a 16, 5 is a 25 of under root. 25, 25, 50. 3I plus 4j plus 5k. 50 of under root. You can write, you can end till here. This is your answer. It's your a cap, this vector, unit vector. That is how you will find unit vector of any along vector.